So today we're going to start chapter 3. We're going to cover section 1, and today we're going to be identifying pairs of lines and angles. So the first two types of lines we're going to talk about are parallel lines and skew lines. So parallel lines, by definition, are coplanar lines that do not intersect. Skew lines, by definition, are non-coplanar lines that are neither parallel nor intersecting. Now we're going to talk about parallel planes. So parallel planes are planes that do not intersect. So for example, in this picture, I could be referring to the top, this plane right here, and the bottom. This would be an example of two parallel planes. I could also refer to the two sides, or even the front and the back. Same thing with my tissue box. Or think of the classroom. The ceiling is parallel to the floor. Those would be examples of parallel planes. And then you would imagine that the ceiling goes forever. Now, if they ask you to name parallel planes from this figure, remember in here, we don't have any italicized or cursive capital letters, so we would have to name the plane with three points. So I could either call the red top plane, I could call that ABH, or I could name it with 4 letters. I could call it ABHG. Just pick a starting point and then go around. I could have started anywhere on this one. For example, I could have started at B and said BHG. It doesn't matter as long as you just go around the edges in order. Then the plane that it is parallel to would be the red one on the bottom. And I could have said that this one is DCE. I could have also called it EFD, any combination of the 4 letters that go around the bottom. These would be examples of parallel planes. Could have also talked about the blue ones on the side, or even if I wanted to color like the back and the front, which is kind of hard to do because it'll overlap. Okay, so again, remember to use 3 or more letters when naming a plane. Anybody still need this slide? Let's try the next one. Done. These are our first 2 postulates from chapter 3. If you happen to read your textbook, this one is labeled as 3.1 and this one is 3.2. Again, I didn't add those numbers to the slides because the numbers are not important to us. You will never be asked to give a number of a postulate, say, outside of this textbook, like if you were doing an SAT, because every textbook numbers their theorems and postulates differently. So the parallel postulate states, if there is a line and a point not on the line, then there is exactly one line through the point parallel to the given line. There will not be more than one, exactly one. Perpendicular postulate states if there is a line and a point not on the line, then there is exactly one line through the point perpendicular to the given line. To demonstrate this, let's say we have a line, a different color here. So let's say we have this line, and then we have another point, and it says if there is a line and a point not on the line, so here's my next point, then there would be exactly one line that you could draw through that point that would be parallel. Same thing for the perpendicular postulate. If you have your original one line then we could say that, and then there's another point that's not on that line, then there would be exactly one line that goes straight up and down that would be perpendicular to that line. Pretty good there? Anybody still need it? All right, let's go on. Another vocabulary word. This time we're going to see the word transversal. And a transversal is a line that intersects two or more coplanar lines in different points. So in this figure here, line M is my transversal. So specific to this diagram, line M is the transversal. The two or more coplanar lines would be line J and K. Now in this figure, when we have two or more coplanar lines that have been intersected by a transversal, these lines form interior angles that are on the inside and angles on the outside. So if I were to sort of box them in and make it like an imaginary box here, then the interior part would be this. And then these would be on the outside of the lines, so these would be exterior. So my interior angles, if you're asked to list them, they're the ones in the red box, and that would be angle 3, angle 4, angle 5, and angle 6. The exterior angles are the ones outside of the lines, and they're the ones in the blue, and that would be angle 1, angle 2, angle 7, and angle 8. Now, keep in mind that your transversal does not have to go up and down vertically. Your transversal could also be horizontal. So for example, I could also have been given a picture this way, and then maybe these are my lines, the two coplanar lines. Again, this could be my line M, my transversal, and then this could be J and K. Again, when you have these two coplanar lines and the transversal, it creates 8 angles. So notice it was already labeled in the other one. So again, 1, 2, 3, 4, 5, 6, 7, 8. So this time the interior angles would be here, and the exterior angles, the angles outside of the lines would be there. So just to be aware of how that looks. Now we're going to see the special angle pairs that exist within these 8 angles. All right, everybody good on this slide? Let's go on. So the first 2 special angle pairs that we have, they're called alternate interior angles and alternate exterior. So this is why it was important that we understood where the interior angles were and where the exterior angles were. So for a pair of angles to be alternate interior, they cannot be adjacent. So there are 2 non-adjacent interior angles, and they're going to be on opposite sides of the transversal. So in this picture, my transversal goes up and down. This is the transversal. It's line M again. And then on opposite sides that aren't adjacent, so like I wouldn't say 3 and 4 because these are adjacent. So what I would have to do is again identify the interior, which are here, And then on opposite sides, so the opposite sides would be 3 and 6, and then 4 and 5. So the pair of alternate interior, 3 and 6 together are alternate interior angles, opposite sides of the transversal. They're not adjacent, and they're on the inside. And then also 4 and 5. Then for alternate exterior angles, remember the outside part or outside area of the two coplanar lines are here. And then opposite sides of the transversal would be 1 with 8 and 2 with 7. Make sense? So these are two special angle pairs. Now we're going to see two more. Yes. Yes. Anybody still need this slide? All right, let's go on. Now, our textbook, they call this first one consecutive interior. Now, some other textbooks, and maybe on a standardized test, they might also call them same side interior. And what I mean by same side interior are two interior angles on the same side of the transversal. So again, here is my transversal. This is my interior portion. And then two angles on the same side of the transversal. For example, 3 and 5 that are interior angles. So this would be one pair. Angle 3 and angle 5 are either called same side interior or consecutive interior angles. And then the other pair would be same side of the transversal, but in the interior, and it would be 4 and 6. Now for the corresponding angles, I'm going to erase that green and red there because I'm going to go ahead and highlight the matches. Okay, so let me go ahead and erase what's on my figure. Now, the description of corresponding angles states two angles in corresponding positions relative to the two lines. So I know this is a mouthful. So maybe one thing that might help you understand what it means by corresponding is if I were to draw a box around each of the group of 4 angles. And I can see that angle 1 is up here in the top left box. So it's going to match or correspond to the top left of the bottom 4. So I would say that angle 1 and angle 5 are corresponding angles. I can do the same thing for the top right corner, 2 with 6. So angle 2 and angle 6 are corresponding angles. They're in the same corresponding position relative to the two lines. I can now do the same thing with the bottom corners. So I could say angle 3 corresponds to angle 7. And then lastly, I can say angle 4 corresponds to angle 8 because it's in the bottom right. Now, another way you can understand corresponding angles is they're on the same side of the transversal, but one is an interior angle and one's an exterior angle. So in relation to the red ones, my blue line here is the transversal. And notice both red ones are on the left side of the transversal, and then one is inside and one is outside, or it like jumps over an angle. Same thing for the green. They're on the same side of the transversal, they're to the left. One is inside, one's outside. Now they can't be adjacent, so you couldn't say 5 and 7. They have to be non-adjacent. Everybody good with these special angle pairs? All right, now we're just going to do a couple of examples and we're done. So again, okay, so on this slide, number 1 is false. A transversal intersects only parallel lines. The lines do not need to be parallel when a transversal intersects them. Answer B, skew lines are not coplanar. This one is true, that is the definition. C, if two lines are coplanar, then they are parallel. This one is false, they could be intersecting. And then D, if two lines are parallel, then exactly one plane contains them. So I could draw a plane around these two. And again, the markings on here, these red markings, these are parallel line markings. Again, I could say that A is parallel to B, but I could not determine that A was parallel to C or if B was to C, because C doesn't have any markings on him. So sometimes in the figure, they're going to look like this, and then other times it might look like this. So again, those markings are not congruent marks. Those are markings indicating that the lines are parallel. Let's try example 2. So here it says, think of each segment in the figure as part of a line. Which lines or planes appear to fit the description? So for the first one, lines parallel to CD. So let me go ahead and highlight CD here. So I'm looking for lines that would be parallel, but they also have to include point A. Now, let's just look for some parallel ones first. So I could show that this one down here is parallel, and so is this one. However, the only one that is parallel to CD that contains point A would be line AB. So AB answers the question. You could also name this as BA. But if it only asked for lines that were parallel, that didn't specify point A being one of them, you could have also said HG and EF, or flip the order of the letters. But because it said to include point A, this would be the only answer. For part B, it wants lines skew to CD containing point A. So let me erase some of these red ones. I'm going to leave the blue one because that's my CD. So again, remember, skew is not going to intersect it and it's not parallel. So an example of a skew line to CD could be AG. That would be a skew line. And AH. Those would be the answers that include point A. And again, you could reverse the order of the letters. Now, another skew line, but it doesn't go through A, could be BG. All right, let's look at C. Lines perpendicular. Let me get rid of these lines. So remember, we need those little right angle marks. So this appears to be a cube, so each one of the corners is a right angle. So something that would be perpendicular to CD, including point A, could be, we could go here and we would say that the only one that includes point A that would be perpendicular would be this line right here, and that would be AD. Now, if you looked for other ones that were perpendicular, you could have also said the one going straight up, DE. You could have said FC. You could have said BC. Any of these going in here, because each of the corners are right angles. But the only one that includes point A would be AD. Then the last one, planes parallel to EFG. So let me go ahead and highlight the plane. So a plane parallel to EFG would be here. And then containing point A would be the top of the box. So I would name that as ABC. You could also call it ADC. Just start here at the A and go around. Again, remember, you only need 3 points. I could have kept going and called it ABCD, but again, all you need are 3. Next slide, we're going to practice naming the 4 special angle pairs. The last slide. So the last slide is asking us to name these alternate interior, consecutive interior, corresponding, and alternate exterior. So again, you're going to find the middle. Those are the interior. These would be your exterior angles. So alternate interior. So here's my transversal. So opposite sides of the transversal, but on the inside, and they can't be adjacent. So we could say 2 and 7 would be a pair of alternate interior, and 6 and 3. These are your pairs of alternate interior. Let me get rid of those marks. Now we're going to look for consecutive interior. So remember, those are on the same side of the transversal. So that would be angles 2 and 3 together. And also angles 6 and 7. Same side of the transversal on the inside. And then we have corresponding angles. So remember, we can draw the box around them, or we can just know that they're going to be on the same side of the transversal. One will be in, one will be out. So here, corresponding could be 1 and 3. They're in the top left. And then I could say 2 and 4. And then I could say 5 and 7. And then lastly, I could say 6 and 8. These are all pairs of corresponding. And then the last one, alternate exterior. So opposite sides of the transversal and their exterior angles. So here, let me erase some of this writing. So exterior, we're looking in the blue. So 1 with 8, and then 5 with 4. and that would be your alternate exterior. So be able to name these angle pairs given a picture.